Good evening, everyone. Welcome to the first episode of the Circular Chat, curated by ICCE, which is a weekly program that invites experts and practitioners from industries, government, multilateral and bilateral organizations, and nonprofits to discuss how they are embedding circular practices and sustainability in their business models. We have hosted 4 seasons so far, and this is our fifth season, and we are going to discuss about in the previous seasons the circular practices and sustainability in their business models we had discussed. We have hosted 4 seasons. The first season had a total of 23 episodes with renowned personalities. The second season conferred about the future of plastics. The third season discussed about climate change, and the fourth season was planned on ESG. We are starting with the fifth season today in collaboration with NSR the Incubation Center for Startups at IIM Bangalore. The topic of this season is circularity in electrical and electronic equipment sector. The chat would help consult the industry experts who will help prepare an action plan for implementing CE principles in the e-waste sector and expedite the focus on CE to ensure the transition from linear to a circular economy in the electrical electronics equipment sector in India. The key focus includes the integration of principles in the design, manufacturing, consumption, and the end-of-life management of EEE. The speaker for our episode 1 on life cycle of electrical and electronic equipment is Mr. Anupam Kumar. Anupam is the founding director at MiniMines, a startup which is supported by NSR in its initial stages. Anupam is a distinguished professional with a background in chemical and polymer engineering from Birla Institute of Technology. With a career spanning various domains, Anupam has showcased his expertise in optimizing heavy metal extraction efficiency during his tenure at Bhabha Atomic Research Center. He has worked extensively on the extraction of heavy metals. He worked with Log9 materials also, and he has played a pivotal role in the development of commercialization of innovative technologies. He has also been involved in fuel cell technologies, specifically aluminium air batteries, led to the retrofitting of the Mahindra E20, showcasing his commitment towards application-oriented approach of sustainable energy solutions. As a consultant for nanomatrix materials and graphene inside TM, Anupam's influence extends to the manufacturing of graphene and the development of graphene silver antiviral technology for various filtration and coating applications. He, alongside with his co-founder Arvind Bharadwaj, spearheads the enterprise dedication to elemental recovery from waste batteries, positioning them as pioneers in battery recycling in the country. Welcome, Anupam. Thanks for coming to the Circular Chat and be present here with us today. Thank you, Anupam.
Thank you, Survi, for those kind words. And it's a huge opportunity to be here and explore your questions here. Before we begin, I would like to share that we are the only startups out of 3 startups from India who is representing at Clean Tech Startup Awards at Vienna Energy Forum at Vienna in Austria.
Okay, that's wonderful, and congratulations for that, Arvind. Yeah. Now, Anupam, we are starting with our question and answer round. So we have a time limit of 30 minutes only. We keep this 30 minutes. So now my first question goes to you, which is like, see, you are from the research background. Beyond being the founding director, you have always you are a researcher and are actively engaged in R&D management, quality assurance, and material development. Would you like to share the diversity of materials that are used in electrical and electronic equipment?
Sure. There are a lot of components that is involved in electronic components, beginning with the metals that is being very rare, such as copper, aluminium, gold, nickel. These particular elements are basically used as connectors, and aluminium is used for as it's a very good thermal radiator. So it acts as a heat sink and a few components. So these components are being as a metal has a very huge importance in the field of connectors and all. Secondly, the other components such as semiconducting materials such as silicon and germanium and gallium are those few minerals that is being used to make semiconductors. Along with it, there are a lot of dielectric material such as Teflon, mica that is being used in high places, electronic equipments. Along with it, sorry. Along with it, there are polymer composites such as fiberglass, reinforced epoxies, or carbon fibers to make circuit boards. So these are few components that is being utilized in different kind of electronic components, which is being used globally and is of a huge importance.
Great, great. So these are different kind of materials that you have, explained. And so what happens to these materials at the end of use? Do you have any numbers from India or globally to help our audience understand the quantum of waste generated in this sector?
So, as a fact, what we have the knowledge is what usually happen to electronic waste is it is being transported or auctioned in the market initially from majority of these stakeholders or MNCs, which uses a lot of equipment and parts of chips and manufacturing parts. So these particular things are auctioned in basically as a rejects in all those MNCs. But usually what happens is it is being transported from one off-takers to another off-takers, and what usually results in the landfills. It basically lands into the landfills, and it has very few components of these particular electronic waste is being consumed by few of these e-waste recyclers, but majority of these components are being disposed of via landfills. And what the data suggest by United Nations Environment Program, that 53 million metric tons of e-waste is being generated annually. And along with it, our country generates around 2.5 million metric tons of electronic waste annually.
I see. So this is a huge amount that we generate, but as you have already mentioned, most of the amount goes into the landfills, and very few, very few percentage goes into recycling. So can you tell us that how much percentage of these materials are recycled or reused in India? In India specifically, how much of it being recycled or reused?
So, we 20% of these e-waste are being recycled genuinely, and the reason behind of this 20% is there's obviously lack of these technology available to recover these valuable components out of these e-waste, and along with it, these components, these valuable elements are used in very small quantities. So what happens usually is recovery of these components doesn't make it economical in the recovery stage. And that is one of the reasons that is being ignored, and which is causing a huge electronic waste disposal in landfills.
That means anybody who's trying to extract this, maybe it is not a profitable business for them. So it's a very tricky, recycling process or process of reusing or extracting the material. The technology that you are using is very, different from the way other materials are recovered. So now your startup, MiniMines, is a part of a revolution in electric vehicle ecosystem to create a circular economy for energy storage devices, which are lithium-ion batteries. So which includes sourcing and collection of the spent batteries and recovery of precious battery-grade materials. Which materials are you actually able to recover? Which are those materials?
So, what the battery is very delicate ingredient in any energy storage devices, and what we have found out is if you try to puncture it or try to manhandle the lithium batteries, even if those batteries are dead, will catch fire or burst into flames. So that is what we do initially is we first of all we deep discharge these waste batteries, and via our proprietary solution we deep discharge stabilizes lithium that is present in your battery. That is the first step. And the further step that has been broken down into different parts, and out of which lithium salts are being extracted in the form of lithium hydroxide and lithium carbonate. Nickel and cobalt salts is being extracted in form of their hydroxide and sulfate form. Along with it, copper and purest form of copper is being extracted by our process. And the whole process combined together, called as hybrid hydrometallurgy, aids in this proprietary process of the recovery of these elemental compounds, which can directly be utilized in different industrial application. Our work doesn't stop here. We forward integrate this recovered minerals and make cathode active material for NMC and LFP grade batteries. So part of our recovered minerals, elemental recovered minerals, are converted into cathode active materials. So that is where our innovation stops. And our whole purpose is to create a value-added products which can be directly utilized into different in-use applications.
Okay. Definitely. So that's a quite, quite technical things over here in processing and reusing and repurposing them and extracting the materials from them. So what barriers do you face in creating a circular economy in lithium-ion batteries? How are you overcoming all of them?
So a very right question. What we have observed so far is there's a very high cost of recycling. The generic technology that is available in the public domain, it's very expensive to process it. Why? The reason behind it, those particular processes being used to recover high-end minerals such as thorium and uranium. If you use the same technology to recover cobalt, nickel, and manganese, that won't give the ROI of the process. That doesn't justify the economical viability of the process. So that is one of the major challenge that every one of us has faced and gone through it. Secondly, there's very lack of awareness of these waste lithium-ion batteries. We believe that these lithium-ion batteries our country basically generates around 50 to 70,000 metric tons of waste lithium-ion battery in our country. But being a citizen of India, we usually keep our mobile phones, our laptops in our cupboards. We don't put it into a proper recycling challenge. So that is one of the challenges that we foresee. But what we believe is in coming future, these challenges can be overcome with the awareness program and different exercise that is going to happen in coming future, that we also trying to plan it out. And there's limited infrastructure for basically recycling technology in India. That is what we believe. We are the one of the few recyclers who are into elemental recovery of these elemental compounds out of these waste batteries. And we believe that in coming future, we can expand and we can address more and more waste lithium-ion batteries. And with doing so, we are making the process much more economical and scalable. That is what our aim is. And that is where our USP and our research is going all together and creating a valuable impact towards circular economy.
Great. Definitely, Anupam, I understand the challenges that you have just mentioned, and I myself see that we have options of as a customer. I have seen that we have options of giving away the plastics, the papers, and the other things, the other metals as for recycling. There are few companies that have come up, those who take the scrap material, but I hardly find anybody who takes e-waste. There are very few companies, those who are asking for e-waste, and e-waste is lying at my home and I'm not able to sell it to the right channel. So maybe many few companies are joining into the e-waste sector also. That's what it suggests also. Is it so?
Yes, truly said. And one of the major issues that I forgot to mention earlier, that usually what happens is these e-waste goes into an informal sector. And what happens is these unorganized sector captures or extract these valuable components out of these electronic waste. And when the actual electronic waste that is arrived to the real recyclers, at that point of time, in those electronic waste, is nothing worth recovering. everything is lost in the between of transfer from one place to another place to another. And these informal sector recover these high valuable magnets out of it, or scrap copper out of the chips. So this is what happens, and this is what makes this industry little tough and little harder to recover, because these if these goes into a right hand directly, so the recyclers will have the financial motive to recover these elemental compounds, and do a recycling process which can actually solve the problem.
Sure. And I hope with some policies or regulations coming in from government, that should also help. Do you feel the need of some policy frameworks coming in, new things should come up to recover the material in, in big amounts? Because awareness has to be created among the customers as well. But then, right, the recovery has to happen maybe through regulations or policy making. What is your take on that?
Ma'am, you're perfectly right. And government has implemented a huge initiative called as EPR. And through EPR, they have created a new portal, a fresh portal, and which is much more stringent and much more transparent, where you have to actually recycle the material, and you have to create valuable products out of it, which proves that you have recycled the product, and which creates a circularity in the particular segment. This is a huge policies that is implemented by our government, has put in a huge win for not only for creating a transparency in between recyclers and EPR. Along with it, it is creating a stronger reverse supply chain in between OEMs, those people who are manufacturing all kind of materials or equipments, are responsible to collect back these batteries and these components back and give it to a responsible recyclers. So this particular policy has made the whole recycling industry very easy and very streamlined.
Right. So I'm sure this is EPR. We have been talking about EPR since long. It has been into practice, but should we be involving more of customers also, something which is, makes customers more responsible? There should be a policy in which, customers feel like that they have to give back what they are not using, or something which is lying in their cupboards unused, and there is value to it. They must understand there is a value to it. So the government should come out with some policies for customers also. Do you think so?
Yes. In fact, one of the similar initiatives that was done by the old vehicles, that if you scrap your old vehicles and dispose it of by responsible recyclers, you get a bonus from the government of India. That same policy can be implemented for electronic waste as well. That is a huge win for handling customer end of this perfectly said.
That's right. So that was a great chat with Anupam here today. Thank you, Anupam. Thank you for your valuable insights on this topic. And now we are closing this session. Thanks a lot for being here and sharing with us all your expertise. Now we are hoping that there are some policy changes that come in, new policy frameworks should come in from government, and whatever is happening, we should put more focus. The people should put more focus on recycling of electronic waste as well, and more people should join forces with you, I hope. And now we will have this next circular chat on 18th of October, next Wednesday, and I request all the audience also to please join us on the next chat, which will be on 18th Wednesday. Thank you. Thanks a lot, Anupam, once again for being here. Have a great day ahead.
Thank you, Surbi. Have a good day. Thank you.
Thank you.